Hello everyone. So this exercise is about hypothesis testing for two population means. So let's check it. So the known standard deviation in salary for all mid-level professionals in the financial industry is $11,000. So it is a known thing before that. So the company A and company B are in the financial industry. Suppose 16 samples from each company are taken of mid-level professionals. The sample mean salary of mid-level professionals in company A is $80,000. So before that, let's try to understand that these companies, these actually populations, are dependent or independent. Since they are two different companies, we can say that they are independent populations, which are company A and company B. So actually let me write here. So both have 16 samples, which is, and A is 16 and B is 16, and the mean for the company A is X bar A, which is 80,000. For the company B, it is actually, so the sample mean salary of the mid-level professionals in company B is $96,000. And there's no given standard deviation for the sample, as you can see. And the company and the company B management want to know that if their mid-level professionals are paid differently on average. So we need to test whether there is a significant difference between the mean salaries or not. So test the hypothesis under 5% significance level. So we don't have any SA and SB values, as you can see. So, but we have a value which is $11,000. So it is a previously known thing about standard deviation. So it is actually standard deviation of the population. So which means sigma is 11,000. So is it sigma A or sigma B? Both of them. So we can write down sigma A is equal to 11,000 and sigma B is equal to 11,000. Okay. Now we know that. We know all the things about the question, and now let's construct the hypothesis. So we want to know that whether there is a significant difference of the salaries on average, which means the means are different or not. Or we can write down the same thing as mu1 is equal to mu2, or mu1 is not equal to mu2. So okay, you can use both of them, doesn't matter. So now we need to first decide, so since it is independent, and we need to decide about the test statistic. So the question was, do we know sigma square is known or unknown? So the answer is it is known. So since it is known, so we have only one test statistic, which is this x1 bar minus x2 bar minus mu1 mu2 over square root of sigma 1 square over n1 plus sigma 2 square over n2. So this is my test statistic. So when I do the calculations, I get these values. So in here, so this is 0. Actually, this is 0. So how can I understand that this is 0? From the hypothesis, actually. So you can see that this is equals to 0. So the original hypothesis gives me the value of mu1 and mu2. So actually this is the first population and this is the second, so I do the indices according to that. So the result will be minus 4.11. So when I just draw the Z graph, and is this a two-sided or one-sided test? So I check here and I can say that it is two-sided because it's an equal not equal sign in here. So my graph is two-sided. So my alpha is 5%. So I can write down here alpha over 2, alpha over 2. From the table you already know that the Z value for this is 1.96. So okay, so I need to just compare my test statistic with these thresholds. So I can say that this test statistics falls into the rejection region. So what is my decision? H0 is rejected. So what does this mean? Comment. Under 5% significance level, there is a significant difference between the salaries in company A and company B. So the question is done. That's all. Thanks for listening.